Let's say you have a man in a birthday cake and he's really excited to blow out the candle so he can eat the cake. So he's going to walk over. Let me just cut and paste him. There you go. He's walked over. And in the moment before he walked over, he was taking a nice deep breath, and we call it inhaling. So he was inhaling air. And then as he was next to the cake, he was going to blow out the candle. So in the moment that he blew out, that's called exhaling. Now we know that inhaling requires a very powerful muscle called the diaphragm. That's one of the most important muscles I want you to remember for inhaling. And the other ones are these muscles that kind of are between the ribs, and they're called the external meaning closer to the outside of the body, external intercostal, meaning between, inter just means between the ribs, costal refers to the ribs. So external intercostal muscles. These two groups, then the external intercostals and the diaphragm, these two groups are going to be very helpful in inhaling air. There are others as well, but these are the two you definitely want to remember. And for exhaling, they're actually important muscles as well. We often think exhaling is just kind of a passive process, but if you're blowing out candles and you really want to force air out, there are actually some muscles here, and the two here that I want you to remember are the abdominal muscles that really help us to generate a lot of pressure. The abdominal muscles, and then these, and the other ones are called the internal intercostal muscles. Internal intercostal, so internal comes up twice, and these are actually a little bit closer to the inside of the body, but they're also between the ribs. So these two muscle groups are the most important ones for exhaling. And just to make sure you get these two straight, just look at these two words and you'll keep them separate. So if things go as planned, he's going to be able to take a nice deep breath, inhale, and then exhale a bunch of air and basically wipe out these candles and eat his cake. So let's make a little bit of space, and I want you to just keep in mind that this was all happening in a very voluntary way. I mean, he wanted to blow out those candles, right? But what about some involuntary things? So let me drop some things that are involuntary, things that actually seem to happen kind of on their own, where the brain is just taking over and you don't really have to think about it. And for the first example, let me draw out the nose. So this is the nose and a mouth, and of course we have on the inside air coming in, and we know the air is going to meet up between what's coming in through the nose and the mouth. And let's say that you have some nerves, and these nerves are right here, and they're sensing some pollen or some, sort of irritant. They're getting annoyed. These nerves are going to be called mechanoreceptors. They're very sensitive, and they can actually pick up all sorts of things like dust. So these mechanoreceptors, if they sense that there's something there, they're going to start sending a signal up to the brain. Now here's the cool part. That's the signal going in. The signal coming out of the brain will basically do a couple of things. It'll lower the muscles here. This is in the palate. It'll lower the muscles there, and it will raise the muscle known as the tongue. So the tongue will come up a little bit. And so now these two are going to work together to basically close off the mouth. You can see how there's just a tiny little space here between the two where a little air could go back through, but most of the air is going to have to go out this way. So when you have a big exhalation, meaning air coming back out, if you're exhaling, you're basically going to force air to go out through the nose. And now you might be able to guess where this is all going to head to. This is what we call sneezing, right? And you say, oh wow, I just sneezed. This is what your body did. It basically kind of forced air through a forced exhalation to go out through the nose and basically wipe out anything that was irritating those mechanoreceptors. So a sneeze is basically just an exhalation or a powerful exhale through the nose. And now you can see how that works. So pretty cool. What's another example of an involuntary thing? Well, let's say that you have your trachea here. Your trachea branches, and you have, of course, some mechanoreceptors that are also here lining the trachea. And if they get irritated, again, they're going to send a signal. You guessed it. They're going to send a signal to the brain. So the brain is going to know, hey, something is bothering my trachea. The mechanoreceptors have told me that. Now, what's at the top of this trachea? The trachea is going to have a little opening. And that opening is going to be where the vocal cords are, right? You've got your vocal cords here on one side, and on the other side, there's a little opening I left in black for you to see where air is going to go through. This is where air goes through usually, and that's how we talk and sing, right, through the vocal cords. So these white things are my vocal cords on both sides. I've got two vocal cords, right, and a little gap between them. And what's going to happen is that if the mechanoreceptors are irritated, then the brain is going to basically do a couple things. It's going to push air out using, of course, remember those abdominal muscles and the internal intercostal muscles. It's going to push air out, and it's going to actually close off these vocal cords just for a small moment. It's just going to close these off. So what's going to happen is that pressure is going to build up. You're going to get lots and lots of pressure. I'm going to put it with an upward arrow and a P, lots of pressure in the trachea, right, as you build up lots of pressure. And then finally, a split second later, it's going to open the vocal cords back up, and air is going to rush out, right? So what we call that when that happens is a cough. We call that coughing. That's the word we use, but really what's happened? We've had a very powerful exhalation using those muscles we talked about. We've exhaled, and then we've closed the vocal cords just temporarily so that you could build up even more pressure, right? Because if you're pushing against something that's closed, you can build up pressure and then pop it open and then have almost like a mini explosion in your trachea, and we call that mini explosion a cough. A final example, let me actually just sketch out very quickly your stomach. Let's say your stomach has got little mechanoreceptors, maybe right here, and these mechanoreceptors are saying, hey, the stomach is pretty full, and so they're sending messages up to the brain to say, hey, brain, we're very distended. So a message is going up to the brain. So that's a message coming into the brain. So what could the brain do? Well, just as before, let me just draw out the trachea kind of splitting off. And in this case, what's going to happen is you have the vocal cords just as before. Let me draw them in like this, right? Little vocal cords. And these vocal cords are initially going to be open and air is coming through. And this is, of course, inhalation, right? We're inhaling right now. Let me write that out. Inhaling. So inhaling air using the muscles of inhalation. We said primarily the diaphragm and the external intercostal muscles. And then just as before, the vocal cords close. So all of a sudden, now you have closed vocal cords. So what's going to happen if that vocal cord closes off or the vocal cords close off? Well, the air is literally going to not be able to come in. It can't come in anymore. So you have this kind of bouncing off where the air literally bounces off of these closed vocal cords. It can't go anywhere. And when you have air rushing in and then bouncing off of the closed vocal cords, you know what we call that? We call that a hiccup. We call that a hiccup. So it's kind of interesting how this is, in some ways, kind of the opposite of a cough, right? In a cough, you had air that was being exhaled and the closed vocal cords, and then here you have air that's being inhaled and you have the closed vocal cords. And of course, when I say the closed vocal cords, it's very, very instantaneous. It's just for a quick moment, and that's what causes the big change. Why we hiccup is still a bit of a mystery, but at least now you have a little bit of insight into how that actually works.